All right, guys. Here is the video going along with our introduction to section 3.3, all about triangles. So we're asking how we can classify triangles. Okay, and you can classify triangles either by their angles or by their sides. We have equally angular triangles in which all angles are congruent. We have acute triangles in which all angles are less than 90, okay? We have a right triangle, of course, in which one angle is 90. We have an obtuse angle in which one angle is greater than 90, but less than 180, okay? And we can also classify our angles according to sides. So classification by angles, equiangular, all angles congruent, acute, all angles less than 90, right, one angle 90, obtuse, one angle, obtuse angle. Okay, by sides, equilateral, all sides congruent. Isosceles, two sides congruent. Scalene, no sides congruent. All three sides are of different length. Okay, we have the biggest thing that we need to know about triangles is that the sum of their angles is 180 degrees. Okay, and we can prove that based on something we already know about our parallel lines and transversals. Okay, so we're going to start out with this set of parallels, CF and BD, as shown up here. They're parallel, and we want to show that these three angles of the triangle, angle 2, 4, and 5, will all add up to 180 degrees. Okay, so I start with the given and work towards this as a proof. So this is going to say that all the angles of a triangle are summed up to 180 degrees. So where does this line come from? Well, it's given, right? It's given to us, okay? Now, what do we look for when we see parallel lines? We look for the angles that we've always seen with parallel lines, okay? The alternate interiors, which would be 1 and 2, or 3 and 4. And we know that the alternate interiors are congruent. So let's see what we get. We know 1 and 2 are equal. Why? Why? Because they're alternate interior, right? We know 3 and 4 are equal. Why? Because we know they're alternate interior as well. Yes? Okay. Now, but what are we after? We're after 2 plus 4 plus 5 equals 180. Do we know another set of angles that add up to 180? I think we do. Up here, 3, 5, and 1, they add up to 180, right? They add up to 180. How do you know that? Because they're not supplementary, angle addition. All supplementary only come in pairs of 2. Remember, they're angle addition. The three of these comprise a straight line, a straight angle of 180 degrees. But guess what? Okay, 1 and 2 are the same, so replace in this line the value of angle 1 with 2. 3 and 4 are the same, so replace, okay, the angle 3 in the fourth line with the angle 4 from here, and we've got what we're after, okay? That all those angles of a triangle, the sum of all the angles of a triangle is 180. Don't forget it. That is something you're going to need to know for most everything we do from here on out, that all the angles of a triangle add up to 180 degrees, okay? So here we go, all right? There's another theorem that we want to look at, okay? This is the exterior angles of a triangle, okay? I ask you to outline the section. The exterior angle is what happens when you extend one of the sides of the triangle. So we have actually three exteriors because we could extend this side here, BA, and pick up an exterior here. But we're just interested in this one. So we extend the side. We extend the side. And what we want to show you is this. So that's what I said here is the angle is formed by extending the side. Okay, angle 1 is therefore the exterior angle. Now, when we have the exterior angle, we have the one that's adjacent to it, angle 2, which is the supplement of that, because, again, you can see the line that they form, okay? And then we have the two non-adjacent, they're 3 and 4, okay? So the two non-adjacent interior angles relevant to this are going to be angles 3 and 4, okay? Angles 3 and 4 are called the remote interior angles, the remote. They're the ones that aren't next to this exterior angle 1, okay? All right, now there's a very important, we'll come to that proof, I guess, later. Let's determine whether the following are true. All angles of an equilateral triangle have measure 60 degrees. Well, the equilateral says all sides are equal, but we're going to find out that if all sides are equal, all angles are equal, and if all the angles add to 360, then each angle is going to be 60. Is there such a thing as an isosceles right triangle? I think that's a contradiction, because this says it has one right angle, okay, and this says it is isosceles. Oh, I'm sorry. Yes, you can have an isosceles right triangle. Yes? Okay. The acute angles of a right triangle are complementary. Yes, well, if one angle is right, then the other two must add up to the right angle, the other 90 degrees. So that's a possibility. There exists an obtuse scalene triangle. I don't see why not, okay? The exterior angles of a triangle is supplementary to the adjacent interior angles. We just saw that in the previous slide, okay? That if you go back, just let me take you back to that, okay? Here's the exterior angle, supplementary to the interior, adjacent interior angle. Let's go back now through some of these questions, okay? If one angle of an isosceles triangle is known, then the other two can be found. If one angle of an isosceles triangle is known, the other two can be found. I don't know about that. I don't think so. Think about it. There exists an acute scalene triangle. Yes, there's such a combination of a triangle having all three sides different and all angles less than 90. Okay. If the angles of a triangle are in a 1 to 2 to 3 ratio, then the angles are measured 30, 60, 90. I believe that's to be the case. Okay. Is there an obtuse right triangle? This is the contradiction. Okay. I had set up here, there is an isosceles right, and I was thinking it was this question. There is an isosceles right, but there is no obtuse right, because that's the contradiction. Here, one angle's greater than 90, the other angle is 90. That already surpasses the 180 degrees allowed, so that's not going to happen, okay? This is the theorem that's involving the exterior angles, okay? And what this theorem is going to tell us, okay, is that this exterior angle, angle 1, is equal to the sum of the two remote interior angles, okay? So we're going to start with this. All we know is going to say that this is a triangle. But in saying that's a triangle, we know that angles 2 plus 3 plus 4 equals 180, okay? But what we want to show is that angle 1 is equal to angle 3 plus angle 4, okay? So, do we know that angle 1 and 2 are supplementary? Yes. They're a linear pair, so linear pairs are always supplementary. Do we know that angles 2 plus 3 plus 4 equals 180? Yes, we do, because, okay, it's a triangle. And we know that triangle angle sum is 180 degrees. Okay, so here we have the sum of 1 and 2 is 180. Okay, the sum of 2, 3, and 4 is 180. So those two are set equal. We've seen this happen before. And we get this by substitution. Okay, get this by substitution. Now guess what? What are we after? We're trying to show that angle 1 is equal to angle 3 plus angle 4. But guess what? Both of these have angle 2 right there. We can take that out, can't we? By subtraction, and get what we were after, that the exterior angle is equal to the sum of the two remote interior angles. The exterior angle is equal to the sum of the two remote interior angles, okay? Let's just do a couple problems and see if we can find the missing angles here, okay? Now remember, what do we know? All the angles add up to 180, so guess what? Well, there's two triangles in here, okay? So let's see. X, we should know X. I mean, here you got 30, up here you got the triangle here on the left side. We're spending 110 degrees, so that means we have 70 degrees left for X. But X and Y are a linear pair, so since X is 70, Y must be 110, and since Y is 110, and you already have 40, that in this triangle here on the right, okay, that would mean that we should be able to find angle Z, because their sum is is 180. So as we said, 70 for X, okay, 110 for Y, 110 and 40. Okay, we're back. So let's show you that. Find all the values of X and Y. And as it just outlines what we just said. The left triangle, the sum of the angles equals 180, so we figure out the X is 70. The right triangle, okay, we look at those three angles, they have to equal 180, but we don't have all of them, but we do know X and Y are supplemental, and there are the angles that we found, and there's all the angles that are missing. Let's see if we can do another one, okay? All right, let's look at this. Okay, find the value of X. Now here, okay, what do we know? Okay, first off, we have parallels. Look for the parallels. What do we look for when you find parallels? You look for all those angles that come into play. Okay, we also have a triangle, and we also have two triangles, both of which are right, because this angle here is C is 90 degrees, right? Okay, so that being the case, what do you think? Well, if this angle's X at B, what about this angle at E? Are they not alternate interior? Yes, okay. So let's look at what we do. The heavy arrows tell us that we have parallels, yes? When we have and the box at C tells us we have a right angle, 90 degrees. Both triangles are right triangles, okay? The relationship between angle A and D must be that they're equal. So here's what we end up getting. We end up finding, okay, that this is 2x, this is x, and this is 90. So we get 90 plus x plus 2x is 180, okay, and therefore we are able to solve that equation and find that x is equal to 30, okay? So we'll look more at these kind of problems in class. All right, review this again if you need to, but remember those two important theorems of this section, okay, that the sum of the angles is 180, the sum of the angles of a triangle is 180, and the exterior angle is equal to the sum of the two remote interior angles. That problem we'll look at another time, okay? One you can think about, take a look at it, see if you can figure it out, but we'll get back to that later, okay?